All right, we're going to go ahead and get started here on homework number 5, and it is called Intercepting Variance. And actually, to start off, the very first few problems are a continuation of last week when we talked about direct variation. And if you remember, last week when we talked about the equation for direct variation, we had y is equal to k times x. So whenever there is an equation that looks like this, where you have a y equals, and then you have a number, and k is our constant. So when you see k, that is called our constant. So you might see something like y is equal to 3 times x. That's a very popular way of writing direct variation. Y equals k times x. So what we're going to do is we're going to continue this. Remember that k is our constant, or also known as the constant of variation. So number one gives you y is equal to 2 times x. And it says, determine whether y varies directly with x. That's the first part. The second part says, if so, find the constant of variation. So let's go to the first part. I like to break things down. Determine whether y varies directly with x. The way you can tell is that if this equation looks a lot like this, where you have a y equals, you have a constant of variation, and then you have y. In this case, you do. You have y equals 2x. So determine whether y varies directly with x. You can say yes, it does. And then it says, if so, find the constant of variation. Well, that's easy. The constant of variation is just right there. It's k. K is the constant of variation. So k is equal to 2. And that's number 1. Number 2 is y is equal to 4x minus 3. Now, you have y, you have equals, you have a 4x, but then you also have this minus 3 on the end. Okay, so this is our equation, y is equal to k times x. There's nothing after that x there. So this is not our equation that we've been using for direct variation. And this minus 3 is what throws us off. So determine whether y varies directly with x. You say no. Y doesn't vary directly with x. Okay? And you don't need to find the constant of variation because it's a no. So all I need to do is circle this and you're good to go. Number 3, it says y equals negative 3 times x. All right, once again, we're looking to see if this is like it says, determine whether y varies directly with x. You pull up the direct variation equation, y equals k times x. And in this situation, we have an equation that looks very similar, and negative 3 is our constant of variation. So I would say yes, k is equal to negative 3. All right, number 4. Now, this one might be a little bit tricky. We have y is equal to 6x equals 0. So what we would do here is, we can't just look at this and say, oh, well, it doesn't look like y is equal to k times x. It doesn't look like it, we're done. Because we can actually make it look like it. Here's what I mean. So we can add 6x to each side, and we get y is equal to 6x. Right? So there's our constant of variation right there. So we can say, yes, k is equal to 6. All right, moving on. All right, so it says for numbers 5, 6, and 7, y varies directly with x. We don't even have to guess. It just tells us there's direct variation. Use a proportion to solve. All right, so I'm going to use a proportion to solve. And a proportion is just a fraction. And you're going to set fractions equal to each other. So let's say that I'll say, how about we do 3 out of every 5 people who took my test got an A. Let's say that was true. And let's say there's 100 people in my class. And we want to find out how many people actually got an A. If 3 out of 5 people got an A, what does x equal? Now I set up this proportion here. If I said 3/5, 3 divided by 5, 3 out of every 5 people got an A. And I'm saying there's 100 people in the class, I put 100 on the bottom because that's out of how many people, right? And then the number on top would be how many there actually was. So the way you can solve this is by cross multiplying. We talked about this in Algebra 1. You guys did a little bit of this also in geometry. So what you do is you take the top number and you multiply it across, right? And we get 3 times 100, and then you set it equal to 5 times x. All right, so if you go through and multiply, you would say 300 is equal to 5 times x. Divide each side by 5 to solve for x. And you would get x is equal to 60. So I know that 60 students in this case would have gotten an A on my test. So another way that people draw this, a lot of times people also they circle them and say, all right, I'm going to do 3 times 100 and set that equal to 5 times x. All right, so we're going to set up these proportions and we're going to solve here. So number 5, it says if y is equal to 4, I'm just going to go ahead and draw my 4. When x is equal to -2, I've went ahead and set up my first proportion. Now, if you look at this, I put the y on the top and the x on the bottom. That's just how I did it, because that's the order of information I got. So it says find x when y is equal to 6. Remember, x is on the bottom. Okay, so it says find x when y is equal to 6. So the proportion that I'm going to solve here, I'm going to solve for this, right? So you can circle them if you want. Just we know we're going to cross multiply. And we can do -2 times 6 is equal to 4x. Maybe I'll just draw parentheses around it so I don't get confused. So -2 times 6 gives me -12. Bring down the 4x, get x by itself. I got to divide by 4 on each side. And I get -3 is equal to x. X is equal to -3. All right? And that would be my answer. Number 6. If y is equal to 6, remember I put the y's on the top and x is on the bottom. That's just what I did. If y is equal to 6, when x is equal to 2, find x, remember x is on the bottom, find x when y is equal to 12. All right, so once again, we're going to cross multiply here. Multiply these across, 2 times 12, and set that equal to 6 times x. 2 times 12 is 24. Set that equal to 6x. Divide by 6, and we get x is equal to 4. That's my answer. All right. Moving on, I'm going to go ahead and pull up a new layer here. So for number 7, it says make a table of x and y values of at least 3 points and use it to graph the direct variation equation. So the first thing it says make a table of at least 3 points. So I'm going to go ahead and create my table here. Now I have to create 3 points. And the way you would do this is you'd start off by picking any 3 x values. Okay, pick any 3 x values. So I like choosing, this is just me, you might like choosing different ones, but to start off, I like choosing 0, 1, and 2. To me, those are the easiest ones you can choose. All right? So it says make a table of x and y values and then use it to graph the direct variation equation. So if I have y is equal to 2x, I want to go ahead and substitute in each of these values. So if I say, all right, y is equal to 2 times 0, well, 2 times 0 is 0. So my answer for y would equal 0. All right, let's put in the next one. Y is equal to 2 times 1. Substituting in this 1 right here. 2 times 1 is 2, so my y would be 2. And the last one, y is equal to 2 times this value right here, 2. 2 times 2 is 4. So we have 0, 0, 1, 2, and 2, 4. All right, now that we've created our table, we're going to go ahead and plot these points. And in the directions it says use these points to graph the direct variation equation. So this table of values I created will be able to be translated over here on my coordinate plane. Okay? It's important to note a few things. When I draw my coordinate plane, I have my x-axis, which I label, and my y-axis that I label. All right, make sure to label these. Everything must be labeled. So starting off, my first point is 0, 0. I'm going to go ahead and label it 0, 0. Then I have point 1, 2, so I move to the right 1, and then up 2, 1, 2. Okay, and the next point is 2, 4. I move right 2, 1, 2, and then up 4, 1, 2, 3, 4. Okay, so this point right here is 1, 2, and this point over here is 2, 4. And I'll go ahead and draw a line that has an arrow on the end. Make sure the line has an arrow on the end. It's not a line segment. That line goes on forever and ever, and that's what these arrows on the end signify, right? That these lines will go on forever, so make sure to include that. All right, and then the last thing I need to do is I need to name my line, and this line is y equals 2x, the equation of my line. All right, so I need to make sure to label my x and y axis. I need to be able to make sure to plot my points and name them, connect them with a line, and then also be able to set the equation to the line, y is equal to 2 times x. All right, let's move to the other example, number 8. Number 8 is y equals negative x. So if I create my table of values, my x and y here, once again, I'm going to choose the first 0, 1, and 2, the same numbers I did for my first example, okay? And I'm going to pull these this way. And what I'm going to do is I'm going to substitute in each of these x values for x, okay, in our equation. So in this, y is equal to negative 0. If I substitute in a 0 there, there's no such thing as negative 0. 0 is just 0, okay? But if I substitute a 1 in, y is equal to negative 1. And then also if I substitute this 2 in here, I get negative 2. All right, so those are my values. I'm going to go through and draw my coordinate plane again and label my y, x, and we have point 0, 0. We have point 1, Oh, maybe I don't want to label it there because it's going to get in the way. I'll put it over here, 0, 0. And I have 1, negative 1. And then I have 2, negative 2. I'm going to draw my line that connects these. Okay. Not the biggest fan of that line I just drew, so I'll make it a little nicer. All right. And I'm going to label my other 2 points. I have 0, 0. I have 1, negative 1. And I also have 2, negative 2. And then my equation for that line is y is equal to negative x. All right. And that's number 8. Move on to the next one. All right, number 9. So for number 9, it says find the slope of the line through each pair of points. Okay, so it says find the slope. This word slope. And what is slope? Well, slope can be written as the letter M. Whenever you see M and it's talking about slope, slope is M. And the way you would write slope is you would take y2 minus y1 over x2 minus x1. And that's how you would find the slope. Now, where do you find these points? Well, if you have 2 points, right, x1 would be the first one, y1 would be the first one, x2, and y2. So number 9, it gives me an example. It says 1, 6, and 8, negative 1. All right, so in this case, 1 is x1, and 6 is y1. 8 is x2, and negative 1 is y2. So let's go ahead and let's substitute these values in to this up here. So I have negative 1. I'll go ahead and write it over here. I'll say negative 1 minus, what was y1? 6 over x2, which is 8, minus x1, which is 1. And I pulled the values right from these 2 points right here. All right, now let's go ahead and let's simplify. Let's say negative 1 minus 6, that gives me a negative 7, over 8 minus 1, that gives me 7. Negative 7 divided by 7 is a negative 1. So it's asking me to find the slope. The slope, in the end, is equal to negative 1. Remember, m is a way of signifying slope. So slope is equal to negative 1. Number 10. Okay, number 10 says 0, 0, and 2, 6. And this is going to be my x1, y1, x2, y2. All right, so you just go left to right and label them like that. All right, so I'm going to have my x2, which was 6, minus 0, over 2 minus 0. Okay, 6 minus 0 is 6. 2 minus 0 is 2. 6 divided by 2 is 3. So my slope in this case is equal to 3. All right, number 11. We have negative 3, 9, and 0, 3. So this x1, y1, x2, y2, we take y2, which is 3, minus 9. And then we have 0 minus negative 3. Okay, that's important. You subtract, and then you have a negative 3 at the end. All right, so 3 minus 9 is negative 6. And 0 minus negative 3, that's the same, subtracting a negative is the same as adding a positive, right? So you would get 3 there. The 0 minus negative 3 is positive 3. And that leaves you negative 6 divided by 3 is a negative 2. So my slope is negative 2. That's my answer. All right. Move on to the next one here. Number 12. All right, so number 12 says write an equation for each line, and it gives you an m and a y-intercept. Now, there's this form that we'll be talking about for an equation called slope-intercept form, okay? And you will hear this often, and you learned about it in Algebra 1, but slope-intercept form, the equation for it is written y is equal to m times x plus b, okay? Just something for you to memorize, right? You'll be using it a lot. So slope-intercept form is y is equal to mx plus b. And it's called slope-intercept because m is our slope and b is our y-intercept. That's why they call it slope-intercept form. All right, y equals mx plus b. And y and x are just the variables used to represent any number that could go in there. All right, so what we want to do is we want to put what they've given us into slope-intercept form. So they've given us, it says m is equal to 3, okay, and the y-intercept is 0. It says y-intercept. I'm just going to abbreviate it y-int. The y-intercept is 0, 2, which means that really the y-intercept is 2. So if we're writing our equation y equals mx plus b, remember m is right there, so y is equal to 3 times x from that 3. So y is equal to 3 times x plus, what's the y-intercept? Well, the y-intercept is 2. Because remember, this is my x value and this is my y. So my y-intercept, in this case, is 2. Okay? So I'm going to go ahead and say plus 2. Now, you might also see y-intercept written like this. Like I said, b is equal to 2. So just, different ways you might see it. So y is equal to 3x plus 2. Let's try again. All right, number 13. Number 13 gives you m, which is the slope, is negative 5. And then the y-intercept, say the y-int, which is just b, is equal to 0, negative 7. So what you get here is, you get y is equal to mx plus b. Your m is negative 5, right? X plus b. Well, what is b? In this case, it's this negative 7 over here, so I'm going to say minus 7. The reason I know that, let's go back to number 12, for example, right? If I were to graph on a coordinate plane 0, 2, notice that if this is my y-axis and this is my x-axis, that this point goes through the y-axis. So let's say a line goes through, it looks like this, right? My y-intercept, where the line intercepts the x-axis, is at 0, 2. The same way this one, right? 2, 1, 2, 3, 4, 5, 6, 7. If there was a point there, and let's just say it was going like that, right? That's an ugly line. Let's say it was going like that. My y-intercept would be right there, where it intercepts the y-axis. All right? That was number 13. All right, number 14 says write each equation in slope-intercept form. Well, we just talked about slope-intercept form up here, so we know that slope-intercept form is going to be y equals mx plus b. Then find the slope and y-intercept of each line, okay? So what it gives me is, it gives me an equation that looks like this. You're like, wait, that's not slope-intercept form. We want to get y by itself here, right? So the way you get y by itself is you'd subtract 5x from each side, And watch this. Now you get y by itself. Y is equal to negative 5x plus 4. I put that negative 5 out in front because that's where x goes, right? mx, negative 5x. So now that I've done this, I've written my equation in slope-intercept form, and now it says find the slope. Well, in this case, the slope is negative 5, and my y-intercept is 4. And that's my answer. I'll do the same thing over here. I got some space over here with number 15, right? I'll say 9x minus 2y is equal to 10. So I'll subtract 9x from each side because I want to get y by itself, right? So this is closer to getting y by itself. It's not totally there yet. But now, if I want to get y by itself, negative 2 times y, we got to divide each side by negative 2. Divide everything by negative 2. And that gives me y is equal to negative 9 divided by negative 2 gives me 9 over 2x. Leave it as a fraction there. You might be tempted to write 4.5. It's better to leave it as a fraction, and I'll explain a little bit more later. So leave this as a fraction, 9 over 2, and then 10 divided by negative 2 gives me a negative 5, right? And in this case, my slope is 9 over 2, and my y-intercept is negative 5. Okay, that's number 15. All right, number 16. Number 16 is negative 4x is equal to negative 2 minus y. Now, I want to eventually get y on that side over there. So what I'm going to do is I'm just going to rewrite this equation like this. I'm going to say negative 2 minus y is equal to negative 4x. I really just swapped all of this, which you can. It's all equal to each other. It doesn't matter what side it's on. And then I'm going to add 2 to each side, and that leaves me with negative y is equal to negative 4x plus 2. Now I got this negative out in front of the y, so I have to divide every piece by negative 1 to get rid of that negative. And that gives me y is equal to 4x minus 2. All right, and then once I've done that, I need to find my slope. My slope is 4, and my y-intercept is negative 2. There you go. Number 17. Number 17, it just says graph each equation. And it gives you an equation. It says y is equal to 2x plus 1. All right, and I'm going to go ahead and I'm going to ask for this one. Let's just go ahead and do our 3 points, right? So let's create our table of values. Let's create 3 points for this one, 1, 2, and 3. And I'm just going to choose the ones that I always pick, 0, 1, and 2, right? And if I'm going to graph this, I first need to complete my table, right? So I'm going to substitute in y is equal to 2 times 0 plus 1. Substitute in this value right here. That gives me 2 times 0 is 0 plus 1 is 1. And then you get y is equal to 2 times 1 plus 1 from this value right here. And we'll say 2 times 1 is 2 plus 1 is 3. And last one, y is equal to 2 times 2 plus 1 from this x value right there. 2 times 2 is 4. 4 plus 1 is 5. So I'm going to go ahead and plot these points. Okay, this is my x-axis. This is my y-axis. I have 0, 1. I have 1 up 3. 1, 2, 3. And I have 2, 5. 1, 2, 3, 4, 5. Okay, so those are my 3 points. So I have 0, 1, 1, 3, and 2, 5. And my equation for the line was y is equal to 2x plus 1. All right, so I went through and plotted my 3 points, 0, 1, 1, 3, and 2, 5, and put them on a coordinate plane, and there's my graph. All right, number 18. All right, I'm gonna do something different for number 18. Instead of choosing 3 points, I'm gonna choose 5 points. So if you ever tell me, hey, you gotta choose 5 points, these are the 5 that I typically choose. I'll choose -2, -1, 0, 1, and 2. You can pick any 5 points that you want. You can choose any 5 points that you want, but this is just what I typically choose. I feel like this is the easiest way of doing it, just because you get lower numbers. So if I substitute in, let's say, y is equal to -3 times -2 minus 2, right? -3 times -2 gives me a positive 6. 6 minus 2 gives me 4. All right, let's go ahead and let's do the next one. -3 times -1 minus 2. That gives me a positive 3 minus 2. 3 minus 2 is 1. Y is equal to -3 times 0 minus 2. -3 times 0 gives me 0. 0 minus 2 is -2. Okay, y is equal to -3 times 1 minus 2. -3 times 1 is -3. Minus 2 is -5. Now check this pattern out. 4 to 1, subtracting 3. 1 to -2, subtracting 3. -2 to -5, subtracting 3. The first homework that we did, the very first problem that we did, was recognizing patterns to make our life a little bit easier. So I can guess here and say, all right, well, we're probably going to subtract 3 here as well, right? So -2, -5, this one will probably be -8. Let's just check and make sure. -3 times 2 minus 2. -3 times 2 is -6. -6 minus 2 is -8. Sure enough. All right. So now that we have our 5 points, let's go ahead and draw our coordinate plane. I have my x-axis and my y-axis. Make sure to label them. And then I have to plot my points. I have -2, and then up 4. 1, 2, 1, 2, 3, 4. Okay, and then -1, up 1. I guess I'll say this is -2, 4. I have -1, 1. 0 minus 2. 0, -2, and I've got 1, -5, so 1, 2, 3, 4, 5, right, and then I have 2, -8, 1, 2, 3, 4, 5, 6, 7, 8, that should end up being about right there. Okay. And I'll plot the rest of my, well, I'll label them 0, -2. I've got 1, -5, and 2, -8. Whoa, that was not a straight line. And if you're plotting these points and you do not get a straight line, let's say you got like a point over here and a point over here, you know that you're not doing it right because this should give you a straight line. When we're dealing with these equations, these are going to be straight lines. My equation is y equals -3x minus 2. Okay, also, if you draw a graph that looks like this, and like, or even like that, I have no idea what any of that is. I need you to label your points. I need you to label your axis. That will not work. It just won't work, guys. All right. see if I can, think I put number 19 on here. Let's do it. Number 19. Okay, number 19 is y is equal to 2/3 x plus 3. So don't worry about the fraction. Okay, don't worry about that. Some of you guys might freak out every time you see a fraction. Act like it's the end of the world. All right, so I'm going to choose 3 points again, but I'm not going to choose my favorite 3 points. What I'm going to do is I'm going to choose 3 points I feel like will help solve this and make it easiest. So my first one I'm going to choose is 0. I put it in the middle because I'm going to choose one that's less than and one greater than eventually. But if I substitute 0 in, 0 times anything is 0. So 0 plus 3 is 3. Okay. Then, if I have 2/3 times y is equal to 2/3 times, I'm going to say 3, put a 3 in for x, plus 3. The reason why I like this one is because that will automatically cancel out these and leave you with 2 plus 3, which gives you 5. Right? Whenever you multiply 3, that's like saying 3 over 1, and you can cancel out those 3's. All right, and then I'm going to use -3. So I'll say y is equal to 2 over 3 times -3 plus 3. These cancel out. 2 times -1, which is -2. -2, that gives me 1. All right, so now when I draw my coordinate plane, okay, I have -3, 1, 2, 3, up 1. I have 0, 1, 2, 3, and I have 3, 1, 2, 3, 5, 4, 5. All right. So I have -3, 1. I have 0, 3. And I have 3, 5. The equation for my line is y is equal to 2/3 x plus 3. I'll label my y-axis, label my x-axis. All right, so I chose these 3x values and substituted them in to get my y value. You can choose any one you want. I just saw that as being the easiest because there's no fraction, there's no decimal, and I knew that because in multiplying, if I have like 2/3 times 3 over 1, I can just cancel these out, and that just gives me multiply across. That gives me 2 over 1, which is the same as 2, right? So that's why I did that. That's why I chose those values. And you'll get better at choosing these values the more that you graph. In Algebra 2, there's a lot of graphing involved. Okay, so we're going to move on to our last problem, number 20. Okay, number 20 says a classmate says the graph of 3y minus 2x equals 5. They said, hey, the slope is 2. And says, what mistake did he make? So you know that the slope's not equal to 2, and you're supposed to find out what mistake this person made. All right? So if I say, all right, if I want to go ahead and put this in slope-intercept form, that will easily show me, right, y equals mx plus b. That will show me what the slope is. So if I take 3y minus 2x equals 5, and I want to get y by itself, the first thing I want to do is I want to get rid of that 2x and add it to the other side. So I get 3y is equal to 2x plus 5. And then I'm going to divide each side by 3, every single term, and I get y is equal to 2/3 x plus 5 over 3. Leave it as a fraction. So they're saying that your friend is saying that the slope is 2. And in this case, we found out the slope is actually 2/3. So a classmate says that that's a slope, what mistake did they make? Well, we can say, well, the slope is really 2/3. And then I can say maybe, if I'm thinking about it, right, maybe they just like stopped here. Maybe they forgot to get y by itself and they stopped up there. And they're like, all right, well, in that case, well, I've got 2x. So I can say maybe the classmate left the equation as 3y equals 2x plus 5 and forgot to get y by itself, or isolate it, right? That's maybe. Who knows? Doesn't give you a ton of information, but that's what my guess would be. All right, that's homework 5. Let me know if you have any questions.